All right, there's a special thing that happens with functions, specifically when we're talking about equations as functions and representing our function as an equation. So this is a really special relationship because functions are represented by equations. Let me write that down. Or that's also a rule. We're doing something to that value, that input, and we're getting something out, okay? Now, an equation will generate ordered pairs. And they generate those ordered pairs by taking in an input. That's typically our x value that results in a certain output. That's typically our y value. Remember, that's going to be your domain and your range. Now, the graph of an equation is the set of all of its ordered pairs, which often forms a line or a curve. Now, the first part of the semester in algebra, we're going to be dealing with specifically functions as a line, and then the second semester, we're going to be looking at curves. But really, it's important that you understand both are a function. And you can look at a function as like a machine that takes an x value and produces a y value. So you could think of your x value like you're inputting gas into your car. And when you drive that car, the car is doing some things to that gas so that the car will run. And then it generates the output, which is the exhaust that comes out of your car. Okay? Now, the x value is called the independent value. And it's the independent variable, and that's because you picked it. The y value is called the dependent variable because the x value, or its value, the y value, will depend on what the value of x is. Now we're gonna look at these tables and we're gonna graph it, and then all we're doing here is I'm saying, okay, my rule says y is equal to x plus 4. So I'm doing something to the value of x, I'm adding 4 to it. So all I need to do is say -5 and add 4 to it. Well, -5 plus 4 is going to give me -1. -4 plus 4 is going to give me 0. -2 plus 4 is going to give me 2. And then 0 plus 4 is going to give me 4. Now these are a set of ordered pairs. So I can go to my graph and I can plot these points. So I'm going to go to -5, 1, 2, 3, 4, 5, down 1. I'm going to do -4, 1, 2, 3, 4, and 0. Then I have -2, and then up 2. And then I have 0, 1, 2, 3, 4. Now, if you notice, they have a straight line. Now, for those of you who were with me this week and watched the video on slope, you will see these are perfect points, right? These points that I plotted on my graph, these are perfect points. So I could determine my slope, okay? Now your slope is from the form of y is equal to mx plus b, and that coefficient with the x is your slope. Well, the coefficient with that x there is a 1. So the slope of this should be 1. And if I look at this and these points, if I would rise 2 units and run 2 units, so that'd be 2, 2, that would give me a slope of 1. Now that's just kind of like a preview and tying into what that lesson is. Other than that, we're just going to go ahead and move on. Don't get too bogged down in understanding that phrasing that I'm just using in terms of this just yet. That's specifically for my A-day kids, which should be fine. My B-day kids, you're going to be a little lost on that. You might not be. You might be fine. Okay, so let's look at number 2 because we're having to do some more stuff to it, okay? Honestly, I want to make my life a little bit easier with number 2 because it's a fraction, and I hate dealing with fractions. We could do this algebraically. We know if we use 0 and I plug in 0, that's going to give me a -2 for the y value, okay? So that's going to be 0 and -2. That's going to be right here. But I can plot some other points. Now, remember, this is your rise over your run. The 3 is your rise. The 4 is your run. Okay? Now, if I plot in the input, so y is equal to 3/4 times -4 minus 2. Okay? Now, I'm saying 3/4 times negative 4. Now, that's the same thing as saying negative 4 over 1. These 4's are going to cancel each other out, and that's going to become negative 3. That's going to be negative 3 minus 2. So that's going to give me negative 5. Okay? Now, I'm going to show you real quick what's going to make this easier for us is we're going to use our handy-dandy calculator. Let me pull my calculator up. And I'm going to go to my y equals, and I'm going to put in my equation. Now, I don't have it on this calculator. I don't have a fraction, so I'm going to use parentheses to use the fraction, and it's 3/2. No, 3/4. And then it's x, and then it is minus 2. Okay, and then I'm going to go to second graph to look at my table list of values. Okay, as you can see, that function that I inputted into the calculator is generating a set of ordered pairs. Now, these aren't all of the set of ordered pairs that have been generated. Okay, these are just the integer ordered pairs. The x values are integers. There's no fractions. Technically, there are still fractions. I could set it up to where this shows my fractions. Let's see. Table value, let's do this because I want you to see it. So 0.5, let's do that. Now, as you can see, now I've added the ordered pairs that contain the in-between, so that means that would be the rational numbers, the a over b. So the ordered pairs of negative 0.5, negative 1.5, and then I still also have my integers in here. The integers are your whole numbers, and including their negatives, okay? Now, let's go ahead and fill out our tables. Our table, we have 4 and 8 is what we haven't filled out. So I'm going to go down here to 4. When x is 4, that will give me an output of 1. And let's look at number for 8. When x is 8, that will give me a y value of 4. Okay, so I'm going to plot my points. So we've got negative 4, 1, 2, 3, 4. And then negative 5. 1, 2, 3, 4, 5. Then we have 4, 1, 1, 2, 3, 4, 1. And then 8, 4 is off our window that we have for the graph. We don't really need it. Honestly, in order to graph, you only need 2 points. So I'm going to go ahead and draw my line. And that's all we're doing for the remainder of the questions. I will see you in the next video where I'm going to go over these questions talking about domain and functions and the range values.